So, good evening, guys. Welcome back. Today, we will be talking about sequences. And in the past discussions, we have seen that sequences play a really important role in understanding real numbers by sequences of rational numbers. So, what's our goal today? What will we learn today? So, what's like the agenda? Today's Today we are focusing our aim is towards understanding why we are learning sequences in the first place, which we already have got an idea, and rather, I should say what we are learning, and we'll say how we are learning. Because these things are often missed in colleges because I don't know, like due to the whole pressure on the whole um, push of and the rush to complete the syllabus, these things are often missed, and or probably teachers assume that students know about this and will get through this. My personal view is that these are the most important things because these are like the fuel of understanding, because whenever you're learning something, let's say you learn something new that is not done in the class, this why and how and what will be guiding you. Okay, this is done due to this reason. Okay, this definition is done to understand something. So uh, we have already talked about this in our videos and past discussions. So please raise your hand if you have watched all the videos in the Google Classroom that I've uploaded. Yes or no? Please raise your hand, or you can say yes in the comment box. Okay, that's great. Okay, so please raise your hand if you have done it, or say yes, anything works. Because I will be assuming you know that because that's what it's given for. You should watch all those. Okay. Okay. So what I will do today, I will also touch upon those ideas briefly. You can take your hands down, uh, and we will also understand what's the. I mean, we will see an overall idea about this. Okay. So we already know that sequences are important to understand. Sequences are important. Sequences are the basic idea is that we will use sequences to understand infinite structures. So if you have done, I don't know if you have been taught probability in such depth, but if you learn major theory or if you have learned aspects of major theory, their random variables have been defined as series of discrete random variables, like any random variable. Okay, you can define like that, and that's important. That's a really interesting aspect that we always try to use discreteness to understand infinite things, because human minds only perceive discrete things. Okay, they cannot distinguish like the infinity is hard for the human mind to comprehend, so that's why human beings always tried. So this is something you should know, that human beings always try to use discrete steps or ideas to approximate the infinite. And you will see that in the numerical analysis, where you use, for example, if you are interested in finding the roots of a function, so use Newton-Raphson method or other methods like that to find that. So essentially, you're using a discrete set. So all the machine learning is based on nowadays something called gradient descent method. So it's nothing a discrete step to find the optimum, to find where the max or optimum is happening. So essentially, what's the goal? The goal is to understand the infinite, or a very minute, the infinitesimal, the very small or the very big, using discrete steps, finite discrete steps. And this is something that has prevailed in the mind, because that's how mind works. Okay, you always try to approximate. So therefore, sequences therefore turns out to be a very important tool to understand mathematics, to understand everything around us. And we'll say therefore a sequence of random variables comes up. Okay, because we're trying to understand, use a sequence of random variables to approximate a certain random variable that we want to know, understand. Okay, or something is happening in a discrete set, we want to model it. So therefore, sequence, idea of sequence is very important. But the question is that, okay, this is why we are learning the sequences. Why? But the question is that what? What we are going to learn? So why, how, and what is something called the golden circle in Simon Sinek's. If you have read, or start with why, or you have seen his TEDx talk, the first thing should be why, the next thing should be what, and the last thing should be how. Okay, that's how I approach teaching. Also, like I tell you the why and then what and how, because this is how the human brain has been developed from the outer region to the inner region. Anyways, coming back to what we are going to learn in sequence. So understand, in sequence, this step is very important. In sequence, we are only interested in, can someone fill it up? In sequence, we're only interested in I already shared it one of the videos. Anyone who wants to share his or her knowledge? Good try. Finding limits, you're right. Um, in some other sense, anyone who
Convergence.
says, yeah, Ravi?
Is it convergence?
You're almost right. So all of you are almost like that limits. But I will call it much more elegantly in terms of, because you don't know what is the limit, right? So I will call it elegantly in terms of the long-term behavior. But the question is that what is a sequence? A sequence is nothing but a function from natural number set to the real number set. Okay. So we take all the natural numbers out here, 1, 2, 3, 4, 5, and it goes on, and we map everything to, let's say, that's some real number, 5.2, 5.3, so 9.9, whatever, pi, e, and it goes on. Okay. So essentially it's a function, and this function can be sometimes, no, this function, so this function can be, this f can be represented analytically. By analytically means that, okay, let's say f of n is equal to sine of n, sine function. F of n is equal to n. F of n is equal to 1 by n. Like where the function is, here sine of x is a function, here x is the function, here 1 by x is a function, okay? But sometimes it cannot be. Sometimes, for example, Fibonacci series is a corresponding format. Like, if you solve it by the characteristic equations, you can form it. But Fibonacci series is a different format. This is very important. This is very important to understand because all the problems you will solve also, it's in this format. Safe can represent analytically. That means in analytical form will be given, or most of the time, safe cannot be represented analytically. So when f cannot be represented analytically, then what to do? So instead of finding the global, so what is analytic function? And a function analytically means you have the global behavior as well, like you have the every information, right? So if now you do not know the global behavior, what you will do is that you will find the local behavior. That means you will find how each element of the sequence is related to the around elements. So that is called a recurrence relation. From many local structures, you can find the global behavior. And for example, Fibonacci series f of n equal to f of n minus 1 plus f of n minus 2, right? F of n is equal to let's say something f of n minus 1, some g of f of n minus 1, right? Some g is known. So essentially, it's related to how each of those an like all those individual terms are related around for each n. This is called a recurrence relation, okay? And this is very important to know because you will see most of the problems in your jam also they will be based on this recurrence relation. So remember this, okay? Uh, we will learn this about this more. So are there other ways? Yes, of course. You can find. You can always find a function. You can always define a function in differential equation format. Okay, that's like, and then you can use that function here. Okay, that function you defined as f hat, f dot means f dash, f dot dot means f double dash, all these things, and then you can define it. But this is not in the syllabus. So, like in our course, we will be focusing on this two type of things. That means a sequence that is f from n to r. You can also represent it as by a1, a2, dot 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 an, and it goes on, right? And each of this can be represented by it's denoted by in two possible ways. One is the analytical way, another is the uh, way of recurrence relation. So it's like um, f of n is equal to sine of n by n, and here f of n is equal to half times f of n minus 1 plus half times f of n minus 2. Okay, there are examples of that. So this is called recurrence relation. This is called uh, so it contains every information. Actually, I would say it's not every information. It doesn't tell you the local information. So I will say it's a global format of saying, and it's a local format of saying. Local means how it's related around neighborhood region, right? So recurrence relation, like corresponding actual input for the continuous motion is differential equation. This tells you the local behavior and the how like the change is happening. It's a global behavior, like how the whole function is all about. You can from there, both of them, you can from local, you can go to global behavior. You can find the actual function, but often we don't do because we don't know how to do that. Like it's hard. So probably this is not done. All of you understood this, guys? Yes or no? That's great. Super. Thank you for mentioning. That's great. Thank you. Okay. Anyone have some doubts? Okay, no one.